So multiplication of whole numbers, as much as you want to deal with negatives right now and stuff, we're just not going to do it. Now it says I will memorize the first 13 multiples table. Maybe that's bad English, but I also don't care. 13 meaning 0 through 12. We do expect a memorization of those multiples. Really, if you can just do up to from like 0 to 9, then that's really all you got to do, because everything else can be stacked and multiplied, which is what we'll be doing for multiplying large and, I mean, not necessarily small, but large values we tend to just stack and multiply. And then at the end, we'll talk about properties of multiplication, which are pretty similar to the ones which we talked about for addition, just slight difference. So we've talked about this before. Math needs to be what we want, okay? So it's going to give us something. We have to change it to what we want it to be. We don't want what the math wants, because if we do what the math wants, it will destroy us, okay? So, yeah, once you understand this, it's true that there's no limit to how much math you can do. You can do algebra, you can do calculus if you wanted to, but you have to understand this. We can take things and change them. So I think we saw an example kind of like this one. You can have 10, in fact, like $10, right? You can have $10, or if you wanted, you could have $7 and $3, right? So if you wanted to change the 10 into a 7 plus 3, I don't know why you'd do it, but you could. And you can do this with math as well. So in fact, if we wanted to, let's take this and change it to a subtraction problem. So you could have $10, but maybe you had $10 because you used to have $13, but then you got rid of $3. You see what I'm saying? So what is 10? And you can ask this of some math professors, and it depends on what class you're in. But if they're really nerdy about it, you could say, what is 10? And they'll be like, whatever you want it to be. Because of this, right? Is 10? 10 could be 13 minus 3. It could be 7 plus 3. Who knows? But it can be whatever you want it to be. And that's the main point here, is we're taking control of the numbers and not allowing the numbers to take control of us to destroy our lives, which many lives have been lost to the math. So we don't want that to happen with us. In fact, I kind of think of it like this. We're operating with the numbers, right? We did with addition, we did with subtraction, now with multiplication. And so it's kind of like, not that I know anything about surgery, like you're actually becoming a math surgeon so you can operate. Does that sound weird? I always get like gruesome thoughts in my mind because it's kind of gory, I would think, with surgery, but I wouldn't know any better either. Okay, so multiplication, this is the symbol that I like to use. You're like, that's just a dot. That's true. Math can use dots for multiplication. Multiplication, just so you know as well, it's the only operation that does not always have to be shown. All other operations must be shown in some form or fashion, but multiplication doesn't always have to be shown. We'll demonstrate that here in a moment, but multiplication is actually just simplified addition. So if you feel like you can add, then you should be able to multiply. I say should because sometimes it's impractical to change things into, to change multiplication into addition, because the numbers get fairly large, like we've seen even with the addition, right? So this goes back to what we were talking about before, and this is what we want. You could say addition is really just a simplified form of counting. So addition is a simplified form of something else, but now we're saying multiplication is just a simplified form of addition. So that's nice. So you could technically just add as many times as you need to get values, but we don't want that. We'd like to be able to take a shortcut, which is what multiplication is. So, vocabulary. The answer to a multiplication problem is called a product. Why is it called a product? I have no idea. Some math nerd in history and time was like, you know what? That's a product. Okay. Why do they call it a sum or a difference? Difference I could explain, but some I don't necessarily know. Maybe it has something to do with Latin or Greek. But wouldn't it be the product? So the values that are being multiplied are called factors. We have to remember that, because I'm going to be using this vocabulary quite often, mostly with factors. Product, I mean, I don't know, sometimes, but enough that we need to memorize this, okay? So if I say we're looking at a factor, 9 and 8 are both factors because 8 is being multiplied by 9, 9 is being multiplied by 8, therefore they're both factors. So that's what a factor is. If you've heard the word factor, boom, there it is. And it's true also, if we wanted to show three terms, three values being multiplied together, let's say like 1 times 2 times 3, now you have three factors. So right here we're only showing two at a time, but it's possible you can have 3 or 4 or more. We shouldn't see a lot of that, but maybe at some point. All right, words and symbols for multiplication. So the words, of course, times is one of them. Distribute. If you hear the word in math, distribute, which we will, we'll talk about distribution, which is also multiplication. Then we need to understand that it's the same thing. Well, I guess I'll talk more about that later. Multiplied by, if you have sets of certain things, then usually you're multiplying. Product would be the answer of a multiplication problem of. And then more specifically, tripled would be the same thing as multiplying by 3. Double is multiplying by 2. So again, you see the multiplication symbols here that I'm using. And then quadrupled would be multiplied by 4. I haven't seen any on the assignments that they ever use anything past quadrupled, but I have seen up to quadrupled, so be aware. And then the symbols we use, the X right here, I try to stay away from X because I think in module 3 or 4, we start using X as a letter and not an operation. So I try not to use X, but you're welcome to do that for now. And then you may see like an asterisk type symbol. I like the dot just because it's quick and easy. Like if I'm writing down, I just boom, put a dot there. Now it's multiplication. But sometimes it's not shown. If it's not shown, then we have to indicate, for example, if I did 3 times 2 like this, that looks like 32, right? So I would have to actually show the operation of multiplication to indicate that. Or what we can do, and again, maybe this is something you remember and are a little bit more familiar with, is we have parentheses. Now it is not the number 32, but this would read mathematically as 3 times 2. For the multiplication, we have to indicate some way that the values or the numbers or digits are being separated by some kind of operation. So repeated addition as multiplication, you're going to have to be able to do this on the assignment as well. But if I were to take 2, now notice it's repeated addition, right? So I have 2 plus 2 plus 2 plus 2 plus 2. That's 5 2s. You can count them. Then you would get 10. Now I'm not going to do the addition, but I'm demonstrating that this 5 times 2 is the same as 5 groups of 2. And that's really what I would look at it, this multiplication as. There we go. So 5 groups of 2, you could say 5 sets of 2, but that's what this is showing up here at the top. 5 groups of 2 or 5 sets of 2. And when we're saying sets, then we're saying we're adding those values together, but we can just multiply like this, which is still 10. Now again, which one do you want? It depends, right? But we're doing what we want, not what the numbers want. So if they show it like this, again, you could do the addition, which would take some time and you'd be fine. But what we want right now is to change this into a multiplication problem, what we want, right? Now it says we can reverse multiplication back to repeated addition if we need it. Again, it just depends on what you want. The other thing I'll point out here is 5 groups of 2 is also the same. If you were to think about this, 2 groups of 5. So if we were to add those 2 5s together, we know it'd be 10 because 2 $5 bills makes a $10 bill. And so we could rewrite this as 2 times 5 equals 10 as well. Now again, why would you need that? I don't know. It depends on what you are using it for. But this goes back to what we saw in addition. You can change the order, and when we change the order, that's called the commutative property. And so there is a commutative property for multiplication as well. All right, so this would be the same as 4 groups of 2. On there. It's 4 groups of 2. Okay, so I'd have to have sets of 2. If I can do this, I'd have, well, I guess we're using blocks, right? So let's pretend like I'm drawing really nice blocks. So there's 2 blocks right there, but I need 4 groups of them, right? So that's a group. There's another group. That's 2 groups. I need 4 of these groups. Boom. there's 4 groups of 2, and it, if you wanted to take this to the limit, you could kind of box these in as a groupings. But what we want here is to know how many boxes there are total. So you could count them and say, well, this is 1, 2, 3, 4, 5, 6, 7, 8, and then you'd know you'd end up with 8 blocks. Or you could say you could count, if you can do this, you'd count by 2s, 2, 4, 6, 8. And then you'd get the same thing. See what I'm saying? But this is what they're looking for on this. 4 groups of 2. I guess the way that I have it set up, there's your sets of 2, but then we have 4 of the groupings. So that's 4 times 2. It's kind of like an area model. Not that we've gone over this yet either, but if you had a rectangle, and we'll pretend like I drew a nice one, you'd have 2 groups vertically, I guess, and then you'd separate this 1, 2, 3 into four groupings horizontally. So again, you could count this, it'd be 8, but it's a 4 times 2 scenario. That's nice, right? And you could model this, and that's great. What we wouldn't want to do here is say, you know what, let's make that, like if we were to look at something like 12 times 85, okay, I probably wouldn't want to model that anymore because that seems impractical. You'd be drawing lines all day long, or I guess you could use technology, but then you'd have to count all those suckers, and we don't want to do that, which is why if we could multiply as a shortcut, then all the better. And that's where our multiplication table comes into play. So with the multiplication table like this one, if you can memorize it, if you can memorize this table, you will be in great shape. So just like your addition table and your subtraction table, I would put this printed out, put it somewhere where you're going to see it all the time and memorize it, right? So, if that's somewhere near the john, that's fine, or, on a bedstand or next to your oven where you're cooking or whatever. Put it there so you can look at this and memorize these facts, okay? Now here's how this works, is you have this column here on the left in blue, and then the numbers are in white, and then at the top you have the numbers in white as well in blue boxes. Those are our factors. So for example, what I'm saying here is that if I wanted to multiply something by 4, it doesn't matter if I start in the 4 row here or the 4 column here, but let's say that we had an expression like 4 times what do you guys want to multiply it by? Okay, so for me, I would start with 4, the 4th row, which is this one, and then I would be multiplying it by 12, so I'd have to go to the column 12 here. Sorry, that didn't come out very well right there, but now I just follow the 4 row along until I get to the 12th one. So you can just kind of highlight the whole thing, and then 12 we would just follow down until we get to the 4th, or the green, where the green matches there, and then that would be the product of 4 and 12. So it's just a matter of following these lines and rows, but each of these numbers in the white boxes with the blue numbers represents a product of something else. Which means, again, just kind of demonstrating, if we wanted this 36 right here, then I would say that would be the same as 9 times this 4. Now, you can do all this math on your own, right? You could say, well, this 4 groups of 12, that's just really 4 groups of 12, so 12 plus 12 plus 12 plus 12, and you could do the addition part of that, right? So you can get these all if you'd like, but there's like 169 of them, so I don't want to do all that addition, which is why the tables, just memorizing the table here will help out a lot. Now for the stuff that we're doing, if you can just get to the 9s from 0 to 9, then you'll be in great shape as well. So if memorizing up to 12, which we would like very much, but if you can't get that far, but you can get up to 9, then again, when we start stacking and multiplying, just like with the addition stuff, you don't need to go beyond that. You can just pull these out as you start multiplying, no matter what the place value is. All right, so same idea. Again, I'm going to use the chart here. I have the chart up because we're assuming that we don't have this memorized yet, right? But hopefully we can get that memorized as soon as possible. Which, by the way, if you can memorize this chart, then the division will happen much easier as well, which we're going over next time. So for this one, I'm going to start with 7 times 3. So I'm going to say the 7 row. And we're going to multiply it by the 3 column, which is here. I'm just going to follow those along. Let's see what this gives me. So there's the 7. And I follow the 3 down there. Boom. 21, right? So 7 times 3 is 21. Bam. Now again, do you want to add 7 3s together? You can. Or you can add 3 7s together. You'll still get 21. Now 8 times 2. So you guys look at the chart. 8 times 2 is, so we know this one's 16. Again, you can look at the chart. The 16, 8 times 2 is this one. Some of you may have looked at the 16 here as well. Notice it doesn't matter if you do 8 times 2 or 2 times 8. You're going to get the same value either way. So we can multiply with expanded form, since expanded form organizes a number by place values, which is really just saying, you know what, just like we did with addition, you can stack these numbers together and just add, well, I guess multiply in this case. But if you look at them by place values, then sometimes it helps. But again, if you do this and you're only doing 2 at a time, that's why we only have to memorize up to 9, technically speaking. But if you can memorize up to 12, that's even better. But this is going to help us with the place value stuff, which is what we're going to start doing when we stack this. All right. So with these multiplied by place value, right? So the 372, I guess I'll do this one in red. You have 370 and 2. So it's expanded form there. And then we're going to multiply this by 65. So what we can do is we can just say, you know what, we're going to multiply this by 60. And then we can also multiply it by 5. So I'm going to rewrite the numbers. 372, but this time we're going to multiply it by the 1-digit value, or the value in the ones from 65 to 5. And really what we end up doing is we find all of these products, and then we just start adding them together. So I'll start with just multiply by 5. Okay, now again, maybe we don't have those memorized yet, but this is all multiplication. So I would start in the ones place value, 2 times 5, which is 10. Now, 70 times 5, you can add 75 times together if you'd like, but 7 times 5 I know is 35. Then all we really end up doing is tacking on a 0 to that. And then, again, I do 3 times 5, which is 15, and then tack on 2 zeros for this one. We'll talk more about that. And then for the 60, so 2 times 6 there would be 12, tack on a 0. 7 times 6 is 42, but then there's 2 zeros there. And then 3 times 6 is 18. And then we have the 3 zeros attached to it. Again, we'll talk more about that 0 thing here in a second. But really all we're doing now is adding these values together. Now that is a lot of addition, and we could look at this by place value. I don't know. Let's start with the 10, I guess. I don't really have anything to add to the 10. I guess maybe the 350. We'll start with these two. So 5 plus 1 is 6. Then we'd drop the 3. Okay, so I've got hundreds, tens, and ones. So I got this 120 over here. Let's add that in there as well. So 6 plus 2 is 8. 3 plus 1 is 4. Okay, so we've taken these 3 numbers. The next all we got is thousands. So let's combine those. We got 4,200 and 1,500. So 4,200, 1,500. And when we add these together, 0 plus 0, 0, 0 plus 0, 0, 2 plus 5 is 7, 4 plus 1 is 5. So that's 5,700, and then we just have this 18,000. Okay, so let's go and add these together. I don't know, I guess we'll start with the smaller ones. So we'll start with the 5,700 plus 480. So 0 plus 0, 0, 0 plus 8 is 8, 7 plus 4 is 11, carry the 1, 1 plus 5 is 6. And then we'd have 6,180, which then we need to take the 18,000 and add it. Okay, so that should get us there. Finally, 18,000 plus 6,180. 0 plus 0 is 0, 0 plus 8 is 8, 0 plus 1 is 1, 8 plus 6 is 14, carry the 1, 1 plus 1 is 2, bam. So looks like our multiplication from that, 372 times 65, is 24,180. Now, that may have been kind of tedious and painstaking right there, but pretty much we're going to be using the same method for stacked multiplication as well, okay? Yeah, that was tedious. Maybe that was even kind of rough. The truth is, once we start multiplying by place values, stacked, then we end up just taking these values, adding them together, and then we kind of stack and add these values together as well. So there's a lot of addition here, but I still think it's better than taking 65 and adding it itself 372 times. So it's just me though. Okay, so we're going to stack and multiply. So again, we are lining up all the place values in order. So if you were to have something like 123 times 45, 1 in the hundreds, 2 in the tens, 3 in the ones, and then times 45. 4 in the tens with the 2, 5 in the ones with the 3. Now this is not addition, but it's going to work kind of like addition, but we have to focus on the place value. Just like we saw on the last slide, what we end up doing here is that you have to multiply the 5 by the 3, the 2 tens, and then the 100. And then you find those products, and then you take the 4 tens and multiply it by the 3 ones, the 2 tens, and then the 100 as well. Okay, so we'll talk more about how to do this in the mathematical way, but you could do it like we just did with the expanded form, looking at each place value, multiplying them all together, and then adding those values together, which is, well, that's kind of what we're going to end up doing, but a little bit different. We're going to hopefully make this so that we don't have to add so many values. Since we got 3 place values times 2 place values, the second one kind of determines how many numbers we add together. So with only 2 place values, the tens and ones, then we should only be adding 2 numbers together. That's the carrying over stuff. If you end up multiplying, let's say that like 3 times 5 is 15, the 1 from the 15, the 110, has to be carried over into the tens place value, waiting for the 5 to multiply by the tens, and then we add that in to however many tens that results in. So if we're going to multiply these, let's stack them first. And I give myself plenty of space here. 423. And then we're going to multiply this by 6 tens and 1 1. Now, to start this off, we don't worry about the 6. We will, but it's not right now. So essentially, I'm just gonna take a box and kind of cover that up, so I don't have to worry about that garbage right now. Okay, so it is there. I just don't want to look at it right now. I want to focus on just 1 times the 423. Okay, so this is where, again, we gotta have our multiplication stuff down. Multiplication tables. 1 times 3 is going to be a 3, so that'd be 3 ones. You got 3 ones times 1 1, which would be 3 ones. Okay, 3 groups of 1. Now next up, this would be like saying you got one group of 20, which would just be, now you could say, well, it's 20 like this, but we already have the 3 occupying the 1's place value. So we just say it's 2 tens right there, right? Just like, kind of like we were with expanded form. And then also you have one group of 400s, which would just be 400s. So the product between 1 and 423 is just 423. It's one group of 423. But now we have to focus on the tens place value. So I'm going to move this over, and I'm looking at the 6. Really what I'm going to do now is I don't want to look at the 1. Okay, so I can keep the arrows there, but I don't want to look at the 1. But that 6 represents 6 tens. So it doesn't matter what I multiply this by, what I'm going to end up with, no matter what, is no 1s. I can't end up with 1s if I'm taking 10s and finding how many groups of 10s there are. Okay, now you can keep the 0 there. You can put it there automatically. It's kind of like a math rule, kind of. But to know where it came from, let's look at the multiplication here. So I'm going to rewrite the problem over here. It'd be 423. It's really times 60. Right here. Now, when I multiply with zeros like that, what I end up with is just an extra 0 to tack on. So the multiplication that I'm going to show, just showing green, right? I would really just look at this as 6 times 3, which is 18. But then I have to have the 0. It's really 60 times 3, which would be 180. Right there. Next up, now it's like I got 60 times, it's really 20 right there. Okay, so I'm now expecting there to be 2 zeros in my answer, and then I would have 6 times 2, which is 12. Next, I would have 6 times 4, but it's really 400, right? It's really 60 times 400. Now you got 2 zeros from the 400, and then the 1 0 from the 60. So I got 3 zeros, and then 6 times 4 is 24. Now, the 0 that we were showing earlier, remember I put that 0 right there? That is because we were multiplying the 6 from the tens place value. And you can see, if we were to look at these zeros right here in the ones place value, that's where that 0 comes from. Because once I'm multiplying by 60, I can't have any 1s result from multiplying by a tens place value. Okay, so the 423, that came from multiplying with the 1, and that was from the 1's place value. This is kind of like my 1's row. And then this is going to be my 10's row, which is, there was six tens. Okay, now we've actually done the multiplication, which is great news, but I'm still going to show it. All right, so let's see, I use green. So again, I'd have 60 really times 3, which would have been 180. Now, I have an extra 100 there, right? So that was, I really just want the 8 tens to combine with the other 2 tens. So what we usually do, and you don't necessarily have to show it like this, but what we usually do is we say, you know what, I'm going to take the 1 from the 180 and move that over here into the next place value. And then whatever product I get, I add that 1 in there. So here's what I mean. The next place value would show 6 times 2. That would have been 12 of the hundreds. But I tack that 1 on. Remember the 1 that we carried over there? I add that to the 12 to make it 13. Okay, now that's that place value, but I have an extra 1,000 from the 13 that I need to carry over into the next place value. So when I do 6 times 4, 6 times 4 is 24. Then I need to add the 1 there to make that 25. So in fact, we can relate that over here, right? The 6 times 3, that was the 180 that we've seen already here. And then the 6 times 2 was the 120. And then the 6 times 4 was 24,000. I said 120, I meant 1,200.
Oh,
now,
so you would just add that.
Yeah, all we're going to do now is add these numbers together. Now that's going to give us this one in the tens row right here. So you'll see 0 plus 0 plus 0, 0, 8 plus 0 plus 0 plus 0. Maybe that's too many zeros. 1 plus 2 plus 0 is 3. 1 plus 4 is 5, and then we drop the 2. Boom, that's the same exact value that we got from the tens place value, multiplying that together. It's just again, the one from the 180 was carried, that's this one here. And then the one from the 1,200 is carried here. Okay, now that we have both place values, we're now ready to add those two together. Whoops. And that will give us the final product. So in the ones place value, 3 plus 0 is 3. Tens place value, 2 plus 8 is 10. So we're going to carry that one over. That's 10 tens, that's 100. 1 plus 4 is 5, plus 3 is 8. Then we got, just drop the 5 and the 2. 25,803. Bam. That would be our final product. So these are the numbers that we have. They're quite large, that's okay. Although I don't think you'd do this in real life, but here we go. So my 36,015, I would have 30,000, 6,000. Now I skipped the hundreds because there's a 0 in the hundreds place value, so I got 10, 110, and then a 5. Now, oh boy, yeah. Maybe I should have put that over here, because we're going to need all the space we can get. So let's get rid of this garbage. And I need this 4 times. 2, crap. I'll do it down here. I'll make it a little sloppy, but we're going to make this work. Okay, now all the numbers that I have right now, they just come from the 36,015, and I'm going to multiply this by 4,213, but I've got to multiply each of those by 4,210 and 3. So at the very bottom here, I'll start with the 3. So again, that would be like 5 times 3, 10 times 3, 6,000 times 3, and then 30,000 times 3, and then we will find these multiplications. Now the good news with this is that we're just multiplying these by however many place values there are. So usually I would say 5 times 3, which is 15 to start with. Then 10 groups of 3 would be 30, and then 6,000 groups of 3 or 3 groups of 6,000. Again, really that's 3 times 6, which is 18, and then 3 zeros tacked onto it. So that ends up being 18,000. And then over here we got 3 times 3, which is old 9er, and then there was 4 zeros attached to that. So that's 90,000. What I've done right there is I've multiplied the ones place value of our second factor, which is 4,213. So I've taken care of the 3 multiplied by the entire value of 36,015. And what we would want to do at this point, or we could do at this point, I'm not going to, you could add these numbers together. Now, since they're practically by place value, it shouldn't be that hard, but we'll get to that, okay? We'll come back to it. Next up, I'm going to multiply by the tens place value in my second factor, which is, well, just 110. Okay, so I'm going to use the bottom left one. It'd be like 5 times 10, 10 times 10, 6,000 times 10, and then 30,000 times 10. So we're going to multiply these together. Multiplication there. Okay, so I got 5 groups of 10, which would be 50, which really, again, I'm just doing 1 times 5 and then tacking a 0 onto it. Next, I've got 10 times 10, which 1 times 1 is 1, and then there were 2 zeros in the multiplication problem. And then I've got 6,000 times 10, so 1 times 6 is 6, and then 1, 2, 3, 4 zeros tacked on. And then 10 groups of 30,000, 1 times 3 is 3. Then we got 1, 2, 3, 4, 5 zeros in the multiplication problem. So 300,000, no problem. Now all of this sum together would have resulted in our tens place value multiplied. So that would, in the problem, that was the 1 times 36,015. Next up, let's multiply the 200s by the values as well. Do this in the top right, so that's 5 groups of I kind of ran out of space there, so it's not exactly aligned by place value, but we're going to multiply all these by 200, which again, this is nice about multiplying by base 10 types values. We can just tack on zeros as we go. So for example, I'll start with a 2 times 5, which is 10, and then we have the extra 2 zeros just tacked on, so that's 1,000. And then in the 10th place value, 2 times 1 would be 2, but then there were 3 zeros in the multiplication. And then 2 times 6, which is 12. And then 1, 2, 3, 4, 5 zeros. That's 1,200,000. And then we also got 2 times 3, which is 6, with 1, 2, 3, 4, 5, 6 zeros. So that's 6 million right there. Okay, the next place value we have is the thousands place value. It's a 4,000. Again, we're only looking at the second factor to multiply into the first factor. So that'd be 5 groups of 4,000, 10 groups of 4,000, 6,000 groups of 4,000. It's going to be quite large. And then 30,000 groups of 4,000. So these are all multiplication problems. Okay, so again, having the zeros at the end of the numbers is nice because I'm going to start with 5 times 4,000. And I'm going to do this a little bit backwards than the other ones I did. And I see there's 3 zeros in the problem, so I can just tack those into my product, and then all I've got to do is 4 times 5. Okay, so that's 4 groups of 5, 5 groups of 4. Either way, you get 20. Okay, now I've got 10 times 4,000, so there's 1, 2, 3, 4 zeros. So again, you can tack those in first if you'd like. And then 4 groups of 1 or 1 group of 4, so that ends up looking like 40,000. And then 6,000 times 4,000, 1, 2, 3, 4, 5, 6 zeros. 2, 3, 4, 5, 6 zeros. And then 4 times 6 there would be 24. 6 groups of 4, 4 groups of 6, doesn't matter. And then last up for us, 30,000 times 4,000, 1, 2, 3, 4, 5, 6, 7 zeros. 1, 2, 3, 4, 5, 6, 7 zeros. And then 4 times 3 is 12. So, this is what we have. And it looks like a lot of addition right there. But the truth is, and again, this is where I think I made a mistake before, is that as we add these together, so I'm gonna go back to the ones in red here. If I were to stack these, this is what we would have. I'd have 90,000, 18,000, 30, and 15. All we got to do is really add these numbers together. So we can find the results by our place values. And so, well, there's a lot of zeros added together, right? So in my ones, I've got 0 plus 0 plus 0 plus 5, which is just 5. And then 0 plus 0 plus 3 is 3, plus another 1 is 4. And then in the hundreds place value, just 0 plus 0, 0, which we need that 0 there. Then in the thousands, 0 plus 8 is 8. And then in the 10,000s, 9 plus 1, well, that's 10 of the 10,000s, giving us a total from the ones that would be 3 times 36,015, ends up being 108,045. And I'll put the comma in there just to kind of clarify the periods. All right, so again, if you do this by place value, you see how this lines up very nicely. There's just ends up being a lot of zeros added together, which makes that very convenient. But let's go now to the tens, and that's our purple values. So I'm going to list these starting with the biggest number, which is 300,000. And then I've got a 60,000. Then 100. And then 50. Boom. See that? Having lined these up, this looks very good. In the ones place value, 4 zeros added together, just a bunch of nothing. And then nothing plus 5 is 5. That's our tens. And then the hundreds is a 1. In the thousands, we got the 2 zeros added together. We need that place value. In the 10,000, 0 plus 6 is 6. And then in the 100,000s, just the 3 drops. So we end up with 360,150 from the tens place value multiplied. Now you'll notice this is, see, remember we had at the top, this is 36,015. Since we multiplied it by 10, really all we did is tack a zero onto that to make this, see, you got the 36,015, but with the zero tacked on there. And that will create a math rule for us, which we'll get into in the next slide. But first, let's go to our hundreds place values in green. So it looks like 6 million. I think I got that right. And then 1,200,000. And then 2,000. And then 1,000. Okay, so we need to add these together. This will give us the sum, or the product of the 200 times 36,015. So in the ones place value, 0 plus 0 plus 0 plus 0. Well, in all three first place values, we got the ones, tens, and hundreds. And then in the thousands, 0 plus 0 plus 2 plus 1 is 3. In the 10,000s, it's just 0 plus 0. Again, I'm going to drop that as a 0. We need that 0. We need to show it. In the hundreds place value, 0 plus 2 is 2. And in the millions, 6 plus 1 is 7. So this means that 200 times 36,015 is 7,203,000. Okay, now we're keeping all these numbers in mind because we're going to have to add them together. But now we go to the thousands multiplied. And so, yeah, some big numbers here. What is that? Oh, it's 120 million. Wow. Okay, this one would be 24 million. And then 40,000. Oh, and then 20,000. Let's add these together. But again, we got a bunch of zeros being added together all the way to the thousands place value. So ones, tens, hundreds, thousands, and then in the 10,000s, 4 plus 2. Again, I'm pretty much ignoring the zeros. These zeros I can't ignore. I need those. 0 plus 4 is 4. 2 plus 2 is 4. And then we got the 1. So what is it? 144,060,000 from the 4 times, sorry, that's 4,000 times 36,015. Well, we do need to finish this off, by the way. So what we're going to do is we're going to take all of those sums that we have in red, purple, green, and orange, and we're going to combine them. We're going to add them all together. So let's list these. I'm going to do it on the right over here because that's where I got some space. We're going to need lots of space. So 108,000, 45. That's from the ones, and then the tens, 360,000, 150. And then the hundreds, that's 7,203,000. And then the thousands, that was 144,060,000. Now, as bad as this looks, again, just because we did it by place values, we end up with a bunch of zeros in some of the place values. So we're ready to add these together. So in the ones place value, 5 plus 0 plus 0 plus 0 is still 5. In the tens place value, 4 plus 5 is 9, and then plus 0 is just going to keep that 9. 0 plus 1 plus 0 plus 0 is 1. 8 plus 0 is 8. Plus 3 is 11, so I'm going to have to carry there into the 10,000s. 1 plus 0 is 1, plus 6 is 7, plus 0 is still 7, and then plus another 6 makes that 13, so we'll carry that one. So yeah, we're seeing some real addition here now. 1 plus 1 is 2, plus another 3, 1, 2, 3 is 5, plus another 2 is 7. So we're using our fingers for that. Nothing to carry. But 7 plus 4, 7, 8, 9, 10, 11. So there's 11 there. And then 1 plus 4 is 5, and then drop the 1. So let's put some commas in here so we can actually see the period. It's 151,731,195 ends up being our final product. So as fun as that method was, and you know, a fair amount of time, let's try this again because it's too much fun, right? Let's have more fun. But we're going to stack and multiply this. So let's see how this goes. We got 36,015. And we're going to multiply this by 4,213. Just straight multiplication. Stacked and ready to multiply. Wanted to say ready to rock, but it doesn't rhyme either. So we always start with the ones place value, right? And we say right here, you're going to see lots of arrows. So get ready. I think I could make this work though. So 3 times 5 to start with is 15. Now, that's 15, but I have tens. So I'm going to carry that over into the next place value so that I have some space for the product. All right, so next up I would have 3 times 1, which is 3, but I have the extra 10 to add on to it to make that 4. Continue then, so 3 times 0, great news about that. Anything times 0 is 0, which we'll get into as well, more, because we want to. So there's no hundreds there. And then 3 times the 6 is going to be 18. But the 1 from the 18 is going to carry over into the next place value. So the 1 is still there. I just moved it up with the 3, which allows me then to multiply the 3 by the 3, which is 9, but then I add the 1 that was carried over to make that 10. Now that 108,045 should look familiar because we saw that after we added all of the place values together from the 3 times the 36,015. Okay, now we took care of the 3 multiplied by the 36,015. What I'm now going to do is multiply, again, this 1 is really 10. Okay, now since it's a 10, that means I will never have anything in my ones place value as I move along through the progression of this multiplication. So I'm putting the 0 there, that purple 0 there, on purpose because I can't have any ones. Now, I've said this before, I think I said this already, but a lot of students forget that 0 on tests. All the multiplication is good, but the 0 right there throws everything else off, and so unfortunately they lose points. We don't want you to lose those points if you use this method. So I don't really care that it's necessarily 10, but I acknowledge that it's 10 with this 0 right here. I'm going to do the same thing with the hundreds place value and the thousands place value, but now I can do 1 times 5, which is 5. Now, why is that 5 in the tens place value? Because I'm multiplying with tens place value right there. Okay, so that'd be 10 times 10, which would be 100. And then I would have 1 times 0, which is 0. And then 1 times 6, which is 6. And then 1 times 3, which is 3. No carrying from this one. Well, we have 360,150. So next up, I would be looking at, again, that 2 isn't just a 2. It's really representing 200. And so no matter what I multiply by, there will be no tens or ones involved. So I got my 2 green zeros there to represent that I'm multiplying with hundreds now. And again, it's going to get a little sloppy because of all the arrows, but 2 times 5 would be 10. Now that the 1 is, again, it's just going to carry over into the next place value. So I don't really want it there, okay, because I'm going to add it with the next place value. Next up, I would do 2 times 1. 2 times 1, which is 2, but I need to add the 1 which was carried over to make that 3. And then I would have 2 times 0, which is, well, 0, nothing to carry. And then 2 times 6, which is 12. So again, I do have something to carry there. The 1 I will carry over into the next place value. So when I do 2 times 3, which is 6, I add the 1 that was carried over to make 7. But now, again, that 4 is really representing 4,000, so I can't have any ones, tens, or hundreds. So again, that's where those 3 zeros come from. Then I have 4 times 5, which is 20. But again, the 2 is extra. I'm going to carry that over into the next place value. In fact, let's get rid of the ones we carried over already. So that was a 2 there. 2. Now I have 4 times 1, which is 4, but add the 2 makes that 6. And then 4 times 0, well, that's 0. 4 times 6 is going to be 24, but I carry the 2 over into the next place value. So then when I do 4 times 3, which is 12, I add the 2 to make 14. So again, this is 144,060,000. That's the same sum we got by multiplying the 4,000 by each place value when we did it in expanded form. And so when I add these together, what do I get? I should get the same value that I had from that last slide. So I'm going to kind of go through this fairly quickly just because of time's sake. But 5 plus zeros is 5, 4 plus 5 is 9, 1 is 1, 8 plus 3 is 11. So carry the 1, 1 plus 6 is 7, plus 6 is 13, carry the 1. 1 plus 1 is 2, plus 3 is 5, plus 2 is 7. 7 plus 4 is 11, 1 plus 4 is 5, drop the 1. And we see now that we have 151,731,195. That's the same answer we got on the last slide. Multiplying by base tens, multiply the non-zero digits in front to the left, which this, by the way, is stuff we've already been doing. Now you take all the zeros from all the factors, meaning both the first factor and the second factor. We should only be looking at 2 at a time. And then you just tack those zeros on to your answer at the end. So that's what I like to do. You can technically reverse this. You can tack the zeros onto the answer and then just multiply the non-zero digits in the front. Do not add zeros between other numbers. They are used in step 1. Yep, that's true. So if you have a 0 that's sandwiched between other non-zero numbers, you can't say, well, I'm going to just include that as part of the product. So here's what we mean by that. And again, we've seen this already with the place value stuff. Perhaps I've done this out of order, which I apologize for. But let's just do 1 times 4. I don't care about the place values on these right now. But what I do know is that 1 times 4 is 4. Okay, so my product will have a 4 in the front, and then at the tail end of this, we're going to tack on zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros tacked onto my 4. Let's see what this is. 1, 2, 3, 4, 5, 6, 7, 8, 9. If I put in commas for the periods, this appears to be 4 billion after I'd done this multiplication. And again, this really helps us because we've seen this already with some of the place value multiplication. So really all you're doing is taking the first numbers, multiplying those, and then tacking on zeros as you go. Okay, multiplication and number lines. So they have this stuff on the assignment, so here we go. The first factor tells you how many groups or sets of the second factor there are, which we've already discussed. Let's see how this works on the assignment. So start your model by placing a dot at 0. So you're gonna have to put a dot at 0. We're just following instructions as we go. And then hop to model the situation, place a dot at each hop. Now again, this is 6 times 2, which would be 6 groups of, of 2. All right, so I'm looking at sets of 2 or groups of 2, meaning that would be one group of 2. And on the assignment, they're not going to let you show the arrows like this. But, you know, you could say they hop and then you can feel good inside. But in either case, that's one set of 2, 2 sets, 3 sets, 4 sets, 5, 6 sets, 7. What am I doing? Let me start over there. Counting's hard for Sal. So here we go. 1 set, 2 set, 3 sets, 4 sets, 5 sets, 6 sets. That's all we needed. Or 6 groups. 6 groups of 2, 6 sets of 2. It doesn't matter, it's the same thing. I see that this ends at 12 after all the hops, and boom, so this ends up being 12. That's what I'd put for my answer, but on the assignment, you're gonna have to put dots at all these place values or numbers until you get to the 12, and then that's where you stop because that's our 6th one. The 0 doesn't count because that's just where we started. Okay, multiplication with rounding. Make sure you round first. This says to the highest place value. This is for front-end rounding. So if they tell us to round to a specific place value, then we will. But looks like we may just be doing front-end rounding. Multiply the rounded numbers. The great news about this is that everything we just did on those last two slides or whatever, is just protecting on zeros as we go. So, okay, so 36,921 times 413,600. Front-end rounding tells us that we're only focused on the front. Now, the 36,000, the 3 is actually in a different place value than the 4. It doesn't matter. It's the front end. So they can be in different place values as you do this front-end rounding, but when we get to the multiplication, again, we'll use that same base 10 stuff. So I'll start with the 36,921. I'm rounding to the 10,000th place value, which is where the 3 is. Immediately to the right is a 6, which is 5 or more, so I add 1 to the 3 to make 4, and then all these place values to the right become zeros. So in other words, 36,921 is closer to 40,000 than it is to 30,000. And then the 413,600, again to the right is a 1, which is less than 5, so the 4 remains a 4. So all these other place values, 1, 2, 3, 4, 5 place values become zeros. And this is multiplication. Okay, now we're just multiplying by base 10s. So I'm looking really starting with 4 times 4, or you could start with the zeros if you'd like. But I know that 4 times 4 is 16. I can usually do a better 6 than that, but how many zeros are there? 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9. I think that's 16 billion. Yep, that's it. We got it. So find a product on the table, write the multiplication for the product. Again, just for the sake of time, someone give me a product there. It doesn't matter which one it is. Boom, 56. Okay, so 56. Now, 56 shows up there, but it also shows up, where am I looking at? Oh, pretty close to it. Yeah, right? Yeah, so the multiplication for that product would have been, you could have said 8 times 7 is 56. But some of you may have said, well, 7 times 8 is 56. And the question is, who is right? Both. That's correct. Both are correct, which means that order does not matter with multiplication. I don't know. I feel like that's kind of a backdoor way into our properties here. That's the commutative property. So commutative order doesn't matter. You can change the order as much as you want with multiplication, and it will never change the actual product. Associative tells us that if you want to, for some reason, multiply somewhere down the line instead of at the beginning, that's fine as well. Doesn't matter where you multiply. Generally, with the associative property, you will see parentheses. So to look at this in the abstract, and math people love abstract, it'd be like A times B times C, but they'd say, you know what, I'm gonna group A and B first, but it actually doesn't matter if I do A times B times C, if I wanted to do B times C first as well. Those would represent numbers, so I apologize for the letter thing. That's abstract, but notice the order did not change. What we did change is which we did first, which is what the parentheses are telling us. So again, order does not change for associative. Distributive is when we multiply and there's some kind of parentheses involved. Not like, well, yeah, kind of like this actually, but sometimes not quite like that. And then 0, anything times 0, this is great, is 0. It's like having 0 groups of lots of stuff. So if you have 0 groups of a lot, then you still have 0. You have nothing, right? Or if you have many groups of nothing, you have a lot of nothing, but you still have overall nothing. So I don't know. Sometimes I feel like that's harsh, but the identity property, this is a very important multiplication property because we're going to revisit this property a lot in, I think it's module 3, the solving equations one. This is coming back at us. So this one, out of all of these, I would say this is the most important one. But these two give us some options. We see this one quite a bit, but again, overall, I'd say this one is most important in mathematics. Some people may not agree with me, whatever. So one group of anything is the same thing. So anything times one is itself, meaning if you have one group of something, then you have that same thing back. Or if you have lots of groups of one, then you have as many groups as there were of something, okay? Sorry for the sake of the video. Which property is being shown? It didn't work again. Dang it, there we go. All right, this first one. Does anyone have an idea? Yeah, so the parentheses, it was around the 8 and 9, then it's the 2 and 8. Yeah, that's the associative property. Associative, which I believe I've spelled correct. 7 times 1 equals 17. The identity, yep. Anything times 1 is itself, meaning you have the identity of what you started with. So the identity. Looks weird to me, but it's late. 12 times 7 times 5 equals 5 times 7 times 12. Yep. Boom. Commutative. Okay. 1,000. Anything times 0 is 0. So that's the 0 property of multiplication. And then finally, 9 times 10 plus 2. Distribution, you may have seen it like this with distributive. They call them distributive rainbows. That's a double rainbow, which, according to YouTube, can make full-grown adults cry, but whatever. It's still distributive. Maybe that's an too old of a reference, but distributive. I don't think they were distributive rainbows, but you get the idea. All right, use the distributive property to make each multiplication easier to complete the mental math.
Can you go back first?
This is kind of a funky question because that reads 2 times 97. And I think right now, most of you would be like, you know what, I can just multiply 2 times 97 and feel really good about that. You know what I'm saying? But they're saying that it's got to be easier. Well, easier is in the eye of the beholder, right? Or the person. It depends on who you are. It's relative. So here's what kind of they're looking at. They're saying you got 2 times 97. So we're going to keep the 2. That's fine. But the 97, we're going to make this an easier value to work with. A value, remember what we said in the beginning? We want to make this what we want it to be, not what they give us.
Isn't it
So
2 times?
here's what they want, because they don't really, addition is fine depending on what number is being used. They want you to relate this to 100 because 100 is a fairly easy number to multiply by. Okay, so what does 97 have to do with 100? Well, it's only 3 away from 100. It's 3 down from 100. So they want something like this. Is that actually easier? I don't know. But that's what they want on this one right here. Now, here's how this would work out. I think that's what they want in the answer. This is what you'd put into the box. If they ask for the actual product, you could just technically take 2 times 97. But here's why you may find this to be easier. If you don't find it to be easier, ignore all this crap that I'm doing right now. But you need that first part. So I would say 2 times 100. 2 times 1 is 2. Tack on 2 zeros. 2 times 3 is 6. And I can do 200 minus 6. I'll skip the math for the sake of time, but that's 194. Okay, was that easier for you? I don't know, but you get to decide. That's it for 1.5. So multiplication, yeah, it can be tedious, it can be long, but it, if you have different colored pens or markers, it can look pretty, but it's still long. It's still pretty tedious, so be prepared for that, okay? Be prepared for some of these to take a long time, especially the multiplication stuff. Again, having you spend 12 hours outside of class per week, spend 10 of those memorizing the table if you must, because if you can memorize that table, then the division will become easier as well.